Today we're going to talk about angle proofs and segment proofs. And just to give you some reminders, up here are your properties of equality and your properties of congruence. Okay, remember that they do have three in common on your property of congruence and your property of equality. Is that reflexive, symmetric, and transitive is what we're showing. I mean, technically here too, we can still add our congruence on the others, but those are the main ones these are showing. Is a lot of times we might see these between equality and congruence. You've got your operation properties, your addition, subtraction, multiplication, division. You've got your distributive property and your substitution property. All right, some new ones though that we need to look at are your definition of congruence. So for the first one, we're talking about, notice the double arrows, we can go back or forth. If we change an equation from an equal sign to a congruence, or if we change it from a congruence to an equal sign, we want to use our definition of congruence. Definition of an angle bisector. Remember, an angle bisector divides an angle into two equal parts. So if I know something's an angle bisector, I should be able to say these two things are equal to each other. Definition of complementary angles. Again, notice the double arrows. If I know something's complementary, I can say they add to 90 degrees. I can also say that if I know something adds to 90 degrees, I can say they're complementary. And I'm using our definition of complementary angles. Same with supplementary, it's a double arrow. So I can go from supplementary to adds to 180 or adds to 180 to supplementary. Definition of perpendicular. I know that perpendicular lines form right angles. So if I know things are perpendicular, I can state the right angles by definition of perpendicular. Now, if I know something's a right angle, then I can say that it equals 90 degrees, and that's our definition of a right angle. Notice these are definitions we have talked about previously. Angle addition postulate, again, something we've talked about before. It tells me that I should be able to take two smaller angles, angle ABD plus angle DBC, and add it to equal the larger angle. This happens when we have adjacent angles. I should be able to take the two smaller angles and add them together to get my bigger. That's our angle addition postulate. Vertical angles theorem. Remember, I know vertical angles are congruent. So if I know two angles are vertical, then I should be able to say that they are congruent, and that's our vertical angles theorem. Our complement theorem. If two angles form a right angle, then I know they're complementary. So if I know two angles form a right angle, then I know they're complementary. That's our complement theorem. And then our supplement theorem, if I know they form a linear pair, then I can say they're supplementary. Okay, this is where we have to go step by step in proofs. Normally we just say, oh, they're a linear pair, they add to 180. But there's a step in between that we skip when we say that. We technically need to say they're a linear pair, so they're supplementary, which means they add to 180. We have to go step by step through that process. So we have to use our supplement theorem there. These we don't see as often, but they do occur. If angle A is complementary to B and angle C is complementary to B, then angle A is congruent to angle C. That's our congruent complements theorem. Right, if angle A is supplementary to angle B and angle C is supplementary to angle B, then angle A is congruent to angle C. Notice they're both supplementary to angle B, just like they were up here. If they're both supplementary, then they have to be the same angle. So that's why we can say angle A is congruent to angle C. Let's go ahead and look at some proofs. Now remember, proofs have to show every step possible, and then they have to give the reason of why that step's allowed to occur. And you can't skip a step, otherwise your proof is invalid. It has missing information. Anytime we start a proof, we start with our givens. So they give us that angle 2 is congruent to angle 3, and I'm going to mark that. Angle 2 is congruent to angle 3. That's our given. Then when we go to our next statement, okay, that's not a given. Okay, we already used this one. It's not a given, so I need to either refer back to my previous statements to figure out where it came from or look at my picture. Well, I'm going to look at my previous statements first. It came from statement 1. Notice the difference was the way it labeled it changed, but that's because I went from congruent to equals. So I'm going to use our definition of congruence to change it from congruent to equal. Now I said that angle 1 and angle 2 form a linear pair. Well, where did that come from? That came from my other given. Okay, so this is our given. And then now I'm saying angle 1 and angle 2 are supplementary. Well, I just said they're a linear pair. So if I don't remember which theorem allows me to go from linear pair to supplementary, when I go back up here, linear pair to supplementary was my supplement theorem. So I need my supplement theorem to be able to say that they're now supplementary angles. And I am abbreviating it. Be careful abbreviating it. All right, so we've got supplement theorem. Now I can say measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, I just said they're supplementary, and supplementary means adding to 180. So that's our definition of supplementary angles. Notice I keep going back to my previous statements to figure out where it's coming from. Where did it build from? Now I've got the measure of angle 1 plus the measure of angle 3 equals 180. Okay, go back to my previous statements. It looks very similar to statement 5. The only difference is I replaced the measure of angle 2 with the measure of angle 3. Well, any time that I replace something, I'm thinking substitution. So I need a statement that says these are equal to each other. And the statement that does that is statement 2. So since I do have that statement, I can say substitution property allows me to replace those. And it's a substitution property of equality since we're dealing with equal sign. And now I'm going from the fact that they add to 180 and that they're supplementary. And by definition, supplementary angles add to 180, and I am allowed to go the other way on that definition. So these are definition of supplementary angles. Okay, make sure you keep referring back to your previous statements to help you with that. And that will help guide you on where to do that, or the picture will also help you. Okay, if we go back to this next example here, they gave us that BE bisects angle ABD and that BD bisects angle EBC. They want us to prove that angle ABE is congruent to angle DBC. So they want to know that these two angles are congruent. First things first, BE bisects angle, or ray BE bisects angle ABD. Okay, that is given to us. And we know that an angle bisector, if this BE bisects angle ABD, then these angles have to be congruent to each other. Okay, which is exactly what this next one states. Angle ABE is congruent to angle EBD. Well, that is our definition of angle bisectors. Then our next statement says that BD bisects angle EBC. Okay, that is also a given. And again, I'm going to use that just to look at my picture real quick. If BD bisects angle EBC, then I know my two smaller have to be congruent to each other. I already marked this with 1 marking, so I'm going to mark this one as well with 1 marking, which really starts to show all 3 angles are congruent to each other. So again, when I look at statement 4, that's what I just marked. Angle EBD is congruent to angle DBC. Those are the 2 I just marked. And that comes from our definition of angle bisector. And notice the last one is already at our answer. Angle ABE is congruent to DBC. Now I can't really just go off the picture on this. I need to look at my previous statements. The two previous statements I can try and use are statement 2 and statement 4. I've got angle ABE is congruent to angle EBD, and angle EBD is congruent to angle DBC. Notice one side of the congruent side is exactly the same on both, EBD, EBD. And by transitive property, that means I can cancel that out and set the other ones congruent to each other, which is exactly what my statement 5 tells me. So this is my transitive property of congruence. And notice it is of congruence instead of equals. All right, my next one. Measure of angle 1 and angle 1 and angle 2 are complementary. That's a given. And then angle 3 and angle 4 are complementary. That's also a given. Both of these came directly from my given. Now they state that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Well, previous statement, statement 1, said they were complementary, which means that they add to 90 degrees. So this has to be my definition of complementary angles. When I look at the next one, it says the measure of angle 3 plus the measure of angle 4 equals 90 degrees. Well, statement 2 referenced angle 3 and angle 4 and said they were complementary, which means they add to 90. So again, this is my definition of complementary angles. Now, when I look at statement 5, it says angle 2 is congruent to angle 3. Now, when I look, I don't really see 2 and 3 referenced together. So I'm going to look at the picture now. Well, angle 2 is here and angle 3 is here. Those are vertical angles. So what allows me to go from vertical angles to congruent? And if I forget, I'm just going to scroll up. Okay, my vertical angles theorem. If two angles are vertical, then they are congruent. So since I know they're vertical from the picture, and I'm saying they're congruent, this is my vertical angles theorem. And then statement 6 says that measure of angle 2 is equal to the measure of angle 3. Well, that's very similar to statement 5, and although my notation changed, it's because I went from congruent to equals. So remember, that's our definition of congruence. All right, now they went to measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. So which ones can I reference for that? All right, I've got 3 that had angle 1 and angle 2 adding together, and statement 4 that had angle 3 and angle 4 adding together. Notice one side of the equal sign is exactly the same as the 90 degrees. So transitive property allows me to cancel that out and set the other two equal to each other. So this is our transitive property. And this is of equality since they're equal signs. All right, so now I've got the measure of angle 1 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. What's the difference between my previous statement? It's that angle 2 got replaced with angle 3. Well, replace means substitute. So I'll go back to my previous statement. Is there's a statement that says these two are equal to each other? Statement 6 tells me that. So that means in statement 8, this is my substitution property that allows me to do that. All right, and then I've got measure of angle 1 equals measure of angle 4. Well, let's refer back to statement 8. What's different? Well, that means I got rid of angle 3 on the left side of the equal side and angle 3 on the right side. Well, when we think of what allows me to move this measure of angle 3 to the other side of the equal sign to cancel it out, that's our subtraction property. So this is our subtraction property of equality. And excuse me, I'm going to put of equality on our substitution property as well. Then the last statement says angle 1 is congruent to angle 4. Well, it's almost identical to statement 9, except I went from equals to congruence, which remember comes from our definition of congruence. All right, so now we're going to look a little bit more at segments instead of angles. Notice you've got your three properties again. Reflexive, showing that something is congruent or equal to itself. Symmetric property, where you're switching sides across that congruent sign or equal sign. And your transitive property, where one side of the congruent or equal sign should be connected, they should be the same, which allows me to cancel those out and set the other two pieces equal to each other or congruent to each other. Your definition of congruence allows you to go from congruent to equals or equals to congruent. Definition of midpoint. If you say something is the midpoint of a segment, so we've got line AB, and if we say that M is the midpoint of AB, then I have to be able to say that AM is congruent or it's equal to MB. And you've got your segment addition postulate. It's the same idea as your angle addition postulate. I've got three collinear points, so I should be able to say that AB plus BC equals AC, or the length of AB plus the length of BC should be the length of AC. So let's do one, and then I want you to try one out on your own. So E is the midpoint of DF. Well, that is given. And I'm going to go up in here and mark just what I'm thinking here. So in this case, if E is the midpoint of DF, that means DE has to be congruent to EF. Or, well, if I look at statement 2, that's exactly what I stated, except with equals. So this is our definition of a midpoint. Our next statement is DE plus DE equals DE plus EF. Well, no clue where that came from. I definitely don't see in the picture, so let's look at our previous statements. Well, the closest I get to is statement 2. What's different? Well, it looks like I added a DE onto each side. So if I add it onto each side, that's when I can say it's my addition property of equality. And then then my next statement says 2DE equals DE plus EF. Well, it's very similar to statement 3. The only difference is I took DE plus DE and made it 2DE. Well, that's just simplifying. That's combining like terms. So my reason is that I simplified. Now I've got DE plus EF equals DF. Well, that's kind of similar to statement 4. The only difference is I replaced 2DE with DF because the DE plus EF is the same on both. So I replaced 2DE with DF, which makes me think substitution. Well, if I go back, give me a second, sorry. What allows me to say DE plus EF equals DF? I don't really see it in my statements. So what I need to think about is looking at my picture next. What allows me to say DE plus EF equals DF? Well, that's our segment addition postulate. That's our segment addition postulate. So although I saw, wait, I can replace this here. I really can't because there's no statement previous that says those are equal to each other. So next, I'm going to move into my last statement that I have 2DE equals DF. Sorry about that. So the last statement says 2DE equals DF. All right, so we have to figure out where that came from. And I'm going to use statement 4 and statement 5 to help piece that together. Statement 4 says 2DE equals DE plus EF, and statement 5 says DE plus EF equals DF. Well, if we notice, one side of the equal sign is exactly the same, that DE plus EF, and our transitive property says if we cancel that out, I can set the other two sides equal to each other. So this is our transitive property of equality. This next one, go ahead and try it on your own, and then we will go through the last one together. All right, so this last one gives us two givens. It says that PQ is congruent to TQ. So we're going to go ahead and mark that. PQ is congruent to TQ. And then it also gives us that UQ is congruent to QS. And we're going to use the 2 marks on that one. And that's their first statement, so that's our given. And then our statement says that the length of PQ is equal to the length of TQ, and the length of UQ is equal to the length of QS. Notice that's really similar to statement 1. We just changed congruent to equal, so that's our definition of congruence. Okay, then our next statements have that PQ plus QS equals TQ plus QU equals TU. Okay, this statement doesn't come from our previous statement, so we need to look at the picture to come up with that. So I've got PQ plus QS equals PS. Okay, that's saying that 2 connected segments equal our longer segment. That's our segment addition postulate. Same for the other statement that came with that. Okay, then I've got TQ plus QS equals PS. Okay, so the question is, where did that come from? So if I look at statement 3, this first equality statement looks pretty similar. The only difference is I replaced PQ with TQ. So I want to think substitution if I have a statement that says those are equal to each other, which in statement 2 I do. So this is my substitution property of equality. My next one, I've got TQ plus QS equals TU. Again, look back at my previous statements. That's very similar to this statement in statement 3, except QU got replaced with QS. Okay, which is up here in statement 2 as well. Okay, since I have that equality statement, I can say substitution property of equality. Now I have that PS equals TU. The statements I haven't referred to in a little bit are my statements 4 and 5. And notice they have one side of the equal sign that's exactly the same, TQ plus QS. So by transitive property, I can say that PS equals TU. And again, that's transitive property of equality. And then our last statement looks almost exactly the same as statement 6, except I went from equal sign to congruent. So this is our definition of congruence. This last one I do want to go over with you just because our statement side is actually blank on a couple spots this time. So RS equals 1/2 RT, that is given to us. This one's a little bit harder to see because you really have to think of your algebra, but just with a lot of letters. How did I go from RS equals 1/2 RT to 2RS equals RT? Well, think of in an equation, how do I get rid of this 1/2? Well, I'd have to multiply the side by 2. And what I do to one side, I have to do to the other. So 2RS would equal RT, which is our next statement. Since I multiplied both sides by 2, this would be our multiplication property of equality. Now we don't have a statement 3, but we do have a reason. The reason is that I use segment addition postulate. Well, I only have 3 collinear points, so segment addition postulate would be that RS plus ST would have to equal RT. So I'm going to write that out. RS plus ST equals RT. Now statement 4 looks pretty similar to statement 3. I've got 2RS equals RS plus ST. Well, if I look at statement 3, that RS plus ST is the same, except instead of RT, I've got 2RS. Okay, replacing means substitution is what I want to think about. So I have to look at my previous statements Do I have a statement that shows those are equal to each other? I do, it's in statement 2. So this is my substitution property of equality. And then my next one says that RS equals ST. Okay, where did that come from? So I would look at this from an algebra standpoint because it's not easy to see in the previous statements. If I use my last statement, is there a way that I can change this? Well, notice I went from 2RS to RS, and I went from RS plus ST to just ST. That means my RS, one of my RS's on each side went away. Well, how would I move this RS? I would have to subtract it to the other side. And that would give me RS equals ST. So since I subtracted on each side, that's my subtraction property of equality. And then now it says definition of midpoint is my reason for my next statement that's blank. Well, if I know RS equals RT, I'm going to mark that in my picture. If I know these two are equal, then that tells me S, since it's right in the middle of the two, S has to be the midpoint. So I will finish this off with S is the midpoint of RT. Also remember too, since this is my last statement, it should be whatever it wanted me to prove. And so I'm going to look back. Does this match what it wanted me to prove? And it does. Go through your statements, go through your definitions and your postulates and your theorems, because that is what's going to help you prove all of your, help you give reasons for all of your proofs. So make sure to go back through and justify those and make sure you understand what those mean and how to use them.